Hey everybody, Burger here for my eighth and final video for this course. I decided to do a presentation on a PowerPoint that I had created some time ago. Figured that I'd share it with you guys now. It's about fire apparatus. Let's get right into it. In the overview, we talk about the history of fire apparatus, types of fire apparatus, such as conventional, aerial, rescue, wildland, hazmat, specialty apparatus. We'll also discuss a little bit about the future of apparatus, where we're going. We've obviously come a long way, but there's still more to come. So basically we went from something like this, old style horse-drawn buggy type of fire apparatus, pumper. Took a lot of effort. We'll get more into that, but obviously we went from something old school like that to something like this is the engine that I have at my station. It's a Pierce fire pumper. It's very different. We'll discuss some of the changes that have occurred, but obviously visually you can see a significant difference from where we started and where we're at today. And you can also figure where we might be going in the future. So this is one of the earliest. This is primitive fire suppression. It was called a fire syringe. It was operated by 3 men, and it only carried 2 to 3 liters of water. Not very much, but it's a start. The first successful engine was created in 1728 by Richard Newsham. It was patented in 1721 and in 1725, so subtle differences were made to it, upgrades, and it was patented again. It held up to 170 gallons of water, and it could pump up to 100 gallons per minute. I would say back then that was pretty good. These early engines, as it says here, were very labor intensive. It took a lot of manpower. A lot of hands were needed to make these things work. So just sheer numbers they needed to throw at fires when they had this old equipment. They needed multiple men. And you needed some to actually work physically, move the pumping mechanism, while you had someone else or multiple people holding the fire stream where it needed to go. The thing needed to be moved by manpower, multiple men having to try to move this thing around, or by horse. So John Erickson created the very first steam fire engine. Almost self-powered, basically. He finally figured out how not to use so much manpower just to get the thing to pump. It was built in 1828, so it took some time to take that large stride in the evolution of fire apparatus. He was awarded the Token of Excellence and Gold Medal from the Mechanics Institute of New York for the design. Okay, it propelled jets of water 1 inch in diameter. So that wasn't really bad. So a lot of water that it forced out, a lot of pressure. Our gal fired it, worked for 5 hours while the others' hand engines would freeze up. This one would work up for up to 5 hours. It was a revolution in firefighting. So the first self-propelled engine was introduced in New York in 1841. So it's the first time that they had an engine that they didn't have to push around by hand or by, it was not a horse-drawn buggy. It didn't need any other power. It could move under its own power. Due to sabotage, I guess some people didn't appreciate them coming in and creating this thing, they were discontinued. So it did not become common again until the mid-20th century. In 1905, the idea of gas engine fire apparatus was attracting great attention. Obviously, it made sense. That was our progression. We were going into vehicles for everyone to move around, so why wouldn't you create a fire apparatus that you could drive around also? It was growing in popularity in England, and Knox Automobile they created the first modern fire engine. So for many years, firefighters sat or stood on the sides of engines. It's like how we're used to seeing them in the old school videos, riding on tailboards and hanging off the side. They were exposed to the elements, and as you can see there, we put there the term tailboard came from. Many lost their lives due to just falling off, which is one of the reasons why we're not allowed to do it today. It seems like it would be kind of cool, but one slip up coming around a curve and it could be deadly. So as buildings grew, so did ladders. We had to figure out how to create new ways to get up these structures and fight fire and perform rescues. So the ladder was mounted onto the truck to reach higher buildings, and this was the first of the aerials. After the Second World War, they installed aerial work platforms to engines. Platform or bucket attached to a mechanical boom or arm. They could reach similar heights as a turntable ladder. They could extend into unreachable corners of burning buildings. We all know what they're designed to do, and obviously they came up with these ideas as soon as the world changed. The fire service tried to change with it. Okay, conventional fire apparatus. The water passes through the pump and then goes to the hoses to fight fire. Multiple discharges, multiple intakes. They usually have a deck gun or a monitor. In some cases, the deck gun is removable to become a ground monitor. And it may have a tank. Most of our fire engines today, what we call the fire pumpers, they have some sort of tank. The size varies. Or it can rely on external water sources, obviously like fire hydrants or drafting from a water source. Okay, modern fire apparatus, usually supplied by hydrants, we discussed that, or can draft. Typically have some sort of foam inductor also. It could be on board, or it could be a portable inductor that you can connect to an inline and into the bucket of foam that you would use to add foam to your fire suppression efforts. Okay, a Class A pumper must pump 1,250 gallons per minute. That's a standard. It must carry a minimum of 750 gallons. It's got to carry hose, it's got to carry ground ladders, and every fire station must have a minimum of one Class A pumper in service. In order to be considered a fire department, you got to have a Class A pumper. Okay, so talking a little bit about a turntable ladder. It's best known as an aerial. We pretty much know what that's for. It's high-rise buildings. A lot of them you can suppress fire from it. It's got a hose line that you can take up to it, and you can reach places you couldn't reach with your regular ground ladders, and effect rescues in places where normally you would not be able to reach any other way. And the ladders are telescopic, which means that they just come out from itself. They don't fold out, they just telescope out. And they can be hydraulic or pneumatic. So we went over some of the key functions, high level points, provide work from platform, we got all that. Okay, you had a tower ladder. They could have, some of them could have a basket. They don't necessarily have to have a basket, depending on what your department needs are or what the preference is. Usually have some sort of master stream attached to these, very sturdy. Okay, tiller ladder. It's mounted on a semi-trailer truck, very large apparatus. Two driver with separate steering. These are some of they use that old school, like we've seen in old school movies, where you have a driver on the back turning so they can make sharp turns. This vehicle is very long, and if you weren't able to do that, the turn radius wouldn't allow it to fit. Pretty much wouldn't be able to go anywhere. So obviously it's designed to be able to still maneuver in narrow streets. Obviously this takes a lot of practice. Both drivers have to be in sync with one another. Okay, a quint. It combines a conventional apparatus. It combines all conventional apparatus into one. Okay, it's ideal for smaller departments. It can perform pump, water tank, fire hose, aerial, and ground ladders. It's got just about everything on it, but as you know, when you start adding so many things onto one, you start losing specialty of one part or another. So it's a give and take. Hydraulic platform. It's articulated, allowing platforms to bend, giving them ability to go over an obstacle. May still have ladder for emergency measure, outfitted with different equipment such as outlets and lights. It's just a specialty, different kinds of specialty ladders depending on your department's needs. Heavy vehicle rescue. All right, this is a specialty firefighting apparatus and EMS apparatus. It's basically a giant toolbox on wheels. It's designed for technical rescue, extrication, confined space, water rescue, etc. Basically, you can throw every specialty tool that you have in this apparatus and you'll be ready for just about any catastrophe you may have to deal with. Okay, rescue engine pumper. All right, this is a combination of a heavy rescue with a pumper. Okay, it's got to deliver at least 1,000 gallons per minute and carry 500 gallons of water. Has the tool carrying capability of a heavy rescue, but lacks the hose capacity of a pumper. So, you combine things again, you lose some. You can't have it all in one vehicle, but we try to get things together that we feel that we may need in our particular departments. Okay, wildland fire apparatus. They definitely vary. There's all kinds of different wildland apparatus. Where I work, we do a lot of wildland, so I've seen very different styles of wildland fighting apparatus. These are separated into 7 classes depending on the capacity and pumping capabilities. Apparatus can vary from a standard engine to a special off-road vehicle, which most of them should be at least 4-wheel drive, and they would vary in heights and capabilities for terrain. Okay. You also have dozers, backhoes. These are commonplace for brush fires to create fire lines. The use of airplanes and helicopters are also widely used to drop water on these fast-moving fires. Here's just a couple of examples. Fire buggy, another brush truck right here on this side, and you got the buggy for deep muddy waters in order to get across to where you might be fighting some brush fire. Many departments have specialized hazmat units. This is an example of one. These are usually massive trucks also. They're designed to carry just about everything they would need to try to contain or safely mitigate a hazmat event. It also needs to house personnel. It's basically a bunch of equipment and a trailer for basically an office, so they can figure out what they need to do. Should also have the different absorbents, like I said, things to mitigate these disasters, and also should have a decon shower set up. We have command support units. Like I said, in a hazmat vehicle, you have a command. They'll have a command center in there, but you also have other ones that will have just a specialized command support unit itself, which is a mobile trailer where they set up command, where they can be comfortable from a distance, so they may still be observant and better decide on how to mitigate whatever disaster they're being taken care of. These are a couple examples of command support units. One is just simply a trailer you attach to a large vehicle that can carry that weight, and another one is self-contained. It's got an engine on it. It's got the box on the back, which, like I said, is just it's a mobile office basically. You have a tanker truck designed to just carry massive amounts of water that you might need in case you don't have a water supply available. The engine pumper can start running out of water, and the tanker can show up and relay pump. In some cases, set up a tank on the ground, fill it, run off, and do a tender, grab water, draft from a stagnant water source perhaps, and then come back and keep filling that. Okay, most tankers have an onboard pumper, so they may be used as an attack pumper also. Most of the time they're just used as a backup. Like I said, they're used to relay, and most are designed to carry anywhere from 1,000 to 5,000 gallons. Okay, hose layer. It's used primarily to lay large quantities of hose if hydrants are far away. Obviously, that's not a great situation to be in. There's a lot of friction loss involved. Should definitely be using large diameter hose if you're going to do long lays like that. So these units are just simply huge hose beds. Fireboats. see these in the city of Miami. They're designed to fight fire from the water along the coastlines or rigs. Basically anything that's underwater. Could be other boats or anywhere near the shore where they might be effective. Okay, they have pretty much, unless something goes wrong with the pump, they have an unlimited amount, unlimited supply, because all the water is running beneath them. They can usually pump up to 38,000 gallons per minute to the fire. It's pretty impressive. They can shoot water up to 400 feet in the air. They can also add the safety of not putting a firefighter in direct contact with the fire. All right, so they can keep their distance, unlimited water supply, just keep them pumping out. Aircraft crash tender. We just got one of these in our department out in Big Cypress. We have an airport, and we just got one we're going to be putting into service very shortly. It's a specialized aircraft for use in airports. It's got special equipment specifically to deal and mitigate with plane and other flying apparatus and crashes. Okay, more about the aircraft tenders and carrier foam. They're pretty much just like any other fire apparatus. They're just, like I said, have special designs to mitigate those kind of disasters. We have motorcycles are used by first responders. That's more on the EMS side. You can use them in dive rescue, arson investigation. You have firefighting and rescue robot, animal rescue units, fire police units. There's all kinds of combinations of things that they're starting to put together now to see if we may be able to get responses to work a little better. Okay, in the future, obviously the main focus for apparatus in the future is safety. We're always worried about safety. We preach that over and over and over again. Safety first. If something happens to us, we can't mitigate the incident that we were called upon. So we don't want to become victims ourselves, so we try to make things as safe as possible for us. Obviously, we're coming up with better things all the time, better tires, brighter lights, definitely more training for everybody, and brakes are always key with these heavy vehicles. Even though they have baffles in the tanks, they're still very heavy, and it helps to really train on how to drive these vehicles and also make sure that the braking system is working properly. Okay, the future, we're looking at trying to get more into one vehicle, being able to just have that one vehicle that can mitigate multiple incidences. So you have the ambulance pumper. So it's a fully functional pumper with a medical box on the back, an ambulance. So you'll have to be dual certified, which most of us are. And so you can either fight fire or take a patient to the hospital on the same vehicle. All right. That's what I got for you on, obviously you see these are the sources that I used. I won't really get into them too deeply. You can see them in the background, but I just wanted to go over some of the changes, and basically you can see from where we've come, how far we've come to now. You can kind of see where we're headed to in the future. So I hope you enjoyed the presentation, and see you guys in class.